So this tutorial is going to work through the part shown on the right here. We'll talk about what this part is and how it's been designed once we actually get started on the tutorial. But before we do that, if we go back up to the top of the tutorial series folder here in Learning Materials, Tutorial Series, I've put a updated config profile on there. So you're going to need to download this updated config pro. And I'm going to start adding letters into these config profiles. So you can see I've added the letter C just to designate that this is the third updated config profile. So obviously the first one was A, then we had B, this is C. So you're going to need to download this. And depending on what browser you're using, this sequence of clicks might be slightly different, but essentially you will need to right click on it and go down to Save Link As or something similar. There should be something where it says Save As or Save Link As. And when you click on that, you're going to need to save it onto your local machine into a folder that you can easily find once you're inside Creo. So we're going to need to find that file wherever you download it to. So I've already done that. So if we just have a look at the Creo interface, so here it is. I've already booted Creo 7 up. And what I'm going to do, I'm going to import that config file and I'm going to apply all the settings inside that config file. So I'm going to click on File menu, Options, and then on this menu I'm going right down to the bottom of this list where it says Configuration Editor, clicking on there, and then I want to go down to this right corner where it says Import Export, and I want to import a config file or import a configuration file. Now I've already saved mine into a specific folder on my machine, so you can see I'm already in that folder, but if you needed to find the folder, you would browse your local computer and find whichever folder the config file has been saved in. So I can just double click on this config file now. So double click, it will load the settings in. Nothing appeared to change here because I've already done this before I started the tutorial, but you will load that in just like we've done, and then you will click on OK. And then you may be confronted with a window just saying, do you want to save these new values from the updated config? You can answer no to that question because you already have a saved copy of those values. That is the config file that I have given you for download. So all those values are already saved in an external file, so we don't need to save them again. So you can answer no if you get that question. So the next thing we need to do before we begin any work is set our working directory. So you click on working directory. Again, you browse your local machine into a suitable folder that you're going to be saving your work into. So you can see in my documents I've just created a folder called Creo Work Directory or Creo Work dir. So that's where I'm working. So I've already done this. So then when you get to that working directory, you click on OK, and at that point I think we will just have a look at the PDF that we're going to be working from. So this is the PDF, and if we need to find where we get that PDF, if we have a look at the learning materials here, scroll down till we see the image of the part that we're going to be working on, and the PDF that we're going to be working from is that PDF there. So that PDF contains all the work that we're going to do in this video tutorial. So if you want to download that and follow it as we're doing it, or maybe just have it as reference material, that's fine. So this is that PDF. So what are we actually going to be modeling or creating in this tutorial? Well, it's essentially a injection molded part from a larger assembly. I haven't fully settled on what the full assembly will be, but it's some form of hand tool. So that's why I've called this tutorial hand tool, and it's only half of the grip from the hand tool. So you can see that really, if this was going to be used as a grip on a hand tool, you would need another half of this kind of clamshell shape, maybe that would look very similar to this half. But for this tutorial, we're just going to model this half of the handle. So I'm referring to this as the front section. In later tutorials we may model the other half of this handle, and that will obviously be the rear section or the back section. So this is what we're aiming to model in the tutorial. And if we zoom in slightly on this second image, then we can see the model tree of features and sketches that we've had to create in order to create this shape. So let's get on with the tutorial itself. So let's scroll down, and at each step there is normally at least one screenshot. Often there are multiple screenshots, and then there's a brief description of what we're expected to do, which is normally above the screenshot. So this one is quite simple. The first feature, it's just an extruded feature. We can see that. I've tried to colour the key feature that we're tackling in each step in this blue colour. So in this extrude, hopefully you can tell that this was created from a sketched closed boundary, and that sketch is a rectangle of 150mm by 40mm, and then the extrude feature itself was extruded by 15mm, and the extrude comes away from the sketch plane in a single direction. So that's kind of the default extrude that you are given, and then you can edit that if you require an extrude that goes in two directions, for example. So let's get going and just create this this first part. So let's find the Creo window. Here it is. So we're going to create a new part. So I'm going to click on new. I will probably give it a descriptive name, so maybe hand tool front might be a reasonably descriptive name. Click on OK. And you may or may not see this screen, but essentially this screen is just confirming what I've set up in that config file, which is our units that we want to use is going to be millimeters, newtons and seconds, and we are creating a part file with relative accuracy. So you may or may not see that window. Sometimes that window is automated and you don't have to click on OK, but if you do see it, you can click on OK. Then we're dropped into the part modeling environment here. So I'm just looking at the three datum planes there, the front, the top and the right plane, and I think what I'll do is I will temporarily just flick back to my PDF just to check what plane this sketch gets created on. So it appears to be created on the front plane. So if I now go back and click on the front plane, click on the extrude icon, which is that icon there, my view will rotate round so that I'm looking normal to the front plane. And then we've already said we're going to create a rectangle, but previously we've used this corner to corner rectangle, and in this instance it's more useful to us to use one of the other types of rectangles. So the center rectangle is the one that we're going to use this time. And then I'm going to go near to the origin point here, and when I'm over the top of it I can see that little blue coincident icon popping up. When that does, I'm going to click and then drag my shape outwards to the left and then click again, and then I don't require the rectangle tool anymore, so I'm going to press escape twice. And then we should be confronted with something like that. So because this is the center point rectangle, it has these two diagonal construction lines included when we create it. And what they are doing is they're allowing us to constrain that midpoint of each line to the origin, so to the point where the planes cross each other. So it's holding that rectangle central, and however we drag the rectangle around now, it will always stay centered around the origin of this part that we're creating. So that's what we require. So I'm just going to tidy up these dimensions. I'm going to drag them to the outside here. I'm going to double click on them and just edit them down to the values that I require. So 150 by 40 is what I need. So that one should be 40. And then I can click on OK, because we've got a closed boundary. We know it's a closed boundary because it's been shaded in this pink colour, and we've fully constrained it through the use of these automatic constraints and our dimensions that we've just edited. So click on OK. Then I'm going to rotate my view so I can better see what's happening with the extrude depth. So that looks okay. We're going in the right direction away from the plane, so that's fine. All I need to do is edit that figure to the 15 that I require. So that's okay. The preview looks good, so I'm going to click on OK. So that's our first feature produced. And you can see that extrude feature now gets listed in the model tree, and the sketch which we needed to create in order to allow us to create that extrude is filed away inside the extrude itself. So it's currently not visible in the graphics window, but if we need to get back into that sketch, we can click on it here. It's now been named as section 1, and we can click on the edit definition icon there, and it takes us right back into the sketch, and we can make any changes that we need. So let's move on with the next feature that we're going to attempt. So we'll move down the page on our PDF. So we've been told to add a round feature. So I don't think we've encountered these before, but essentially this is what the round feature achieves. So if we have a look at our block currently, it has a sharp edge there where that top face and that left hand face meet each other at 90 degrees, and it has another sharp edge there. And the round feature essentially deletes that sharp edge where those faces meet, and it smooths the transition between the two faces using a radiused face. So a nice portion of a cylinder essentially, to actually smooth the transition from one face to the next face. And the way that we instigate the round, or the quickest way to use the round tool, is to actually click on an edge that you want to get rid of and replace with the round. So I'm going to click on this edge here, click, and then of the icons that are offered to us in this quick access toolbar, that is the round icon. So if you're wondering which icon you need to click on, if you temporarily hover over the icons, these tool tips will pop up and name the icon. So this one is round, but more than that, it will tell you a little bit about what the tool actually does, or what the feature actually does. So we'll click on round. We get a preview of what the round feature will currently look like, and as I've been saying in these early classes, it's entirely acceptable to, when you get a preview like this, to click and drag on the yellow circles just to get a feel for what the feature actually is, how it behaves with differing values, and just really educate yourself about what that feature does and how you edit it. So you can see what this round feature is doing. It's growing and shrinking, and that figure that keeps changing as we drag, that is the radius of curvature. So if you think of this round as a part of the outside surface of a cylinder, which is essentially what it is, then that is the radius from the center of the cylinder itself out to the edge. So it's just a radius like you get on a normal cylinder or a circular sketch. So what radius do we want to set this to? 15. So that's 15 millimeters in there. So I'm just going to type 15, press the enter key. So that's that round set up. And while I'm in this round feature, while I'm creating it, I have the ability to add multiple different rounds to different edges. So I'm going to add a round to this lower edge, and you can see I haven't okayed this round feature. I'm still in the round feature, so I'm just going to click on the bottom edge, and then I get a second round feature, and I can edit the value of this one to 20 in this case, and it's independent of the radius that I've set for this top round. Now if we want to understand a little bit more as to how might one go back into the top round and change the radius of that, we have to open up some of these tabs, or one of these tabs specifically, in the round menu area at the top of the screen. So I'm going to click on this tab, Sets, and in there I've got Set 1 and Set 2. Because I've clicked on two different edges, edge 1 was placed in a set which was named Set 1, and I can edit the radius down at the bottom here. So if I wanted to change this one to 10, let's say, I can do that. So let's put it back as it was on 15, and then if I want to edit any rounds which are currently in Set 2, I select Set 2, and then I've got access to change that radius. So that's how the system behaves if you just click on edges whilst in the round feature. It will add them to new sets. So we've got two sets within this one round feature. So I'm largely happy with that round, so I'm going to click on OK. So we've completed the next step. So let's have a look at the PDF, see what we're going to be tasked with doing next. So this feature is slightly more complex in that we have to create a new sketch, and it is an extruded feature, so we are somewhat familiar with extrudes now. It's an extruded feature which is going to remove material from our part. So hopefully you can see this is our part. There are the two rounds that we've just put on the leftmost edge, and this new extrude feature, which we're in the extrude menu here in this screenshot, it's showing that a portion has been removed from the top of our part there. It's showing in that yellow colour, and it's a little bit harder to see, but there's also been a portion trimmed away at the bottom there as well. And the sketch that did the trimming at the bottom of the part is clearly visible there. So there's a sketch with a straight line in it, and then it seems to have sort of a swooping curved shape up above the line that's trimmed this material away. And there's a similar sketch at the top, although it's slightly harder to see. The straight edge on the sketch is there, it's that yellow line, and then the sketch is kind of merging into the back of that yellow face there. So the details of that sketch are shown below. So let's initiate that extrude and start to create this sketched shape. So before we do that, we can see that it's being created on the front plane, so we need to know that before we initiate it. So I'm going to click on the front plane, tell the system I want to create a new extrude. The view will rotate round, and then the tool that we're going to use to create those swooping curved lines is the spline tool. So I'm going to select the spline tool from the sketch menu at the top there, and my first point that I'm going to drop, or that I'm going to click, I want this to be locked to the top edge of the part like that. So when I go near the top edge of the part, two things happen. The top edge highlights in green. That's how I know if I click now that I'm going to lock my point onto that top edge. But more than that, the coincident icon appears next to my pointer as well. So that's that little blue icon that has a line in it with a blue spot on it. That is the coincident constraint. So when I see those two things, I'm going to click to drop my first point in my spline. Then I'm going to go to approximately here. I'm going to click again. Then I'm going to go over here. I'm going to click again. And the final click is coming up, the fourth one. And the fourth one, I want to go to the point where my round meets the flat face on the top of this part. So that will be there. And I can tell that it's there because the top edge is highlighted in green and the end of the top edge has got that blue square on it. So I know that I'm at the transition point between the flat face and the flat edge on the top of the part and that round feature. So that's where I want to place my final fourth point on this spline. So I'm going to click. And then the system is offering to continue this spline onto a fifth and sixth and seventh point. But I don't need that, so I'm going to press the escape key to stop drawing that particular spline. So I still have the spline tool selected, so I can draw more splines now without reselecting the spline tool. So I'm going to put this lower one in. I'm just going to have a quick look at my sketch that I'm working from. So this one has 3 points. It has one there, locked to the lower edge of the part. It has one there, and then it has one all the way over here. Again, locked to the lower edge of the part. So I'm going to sketch a spline that approximates that. So first click. I'm going to avoid going exactly vertically below the first point of that upper spline. That's not something that I need. So I'm going to purposely either go slightly to the right or slightly to the left, just so that it doesn't put a vertical constraint between the two end points. I don't want that. I just want it locked onto this bottom edge. So there is fine. So click, and then click. And then this time I don't want to go all the way over here to where this lower round turns into the flat face on the bottom of the part. I want to terminate this spline somewhere there instead. So it still needs to be locked onto the lower edge of the part, which it is going to be if I was to click here, but it isn't as far forward or as far to the left as we're looking at it as the upper spline is. So somewhere there is fine. And then I don't want to sketch any more spline points on that lower spline, so I'll press escape once. And then I don't need the spline tool selected. You can see at the top of the screen there, the spline tool is still shaded in a slightly darker grey, but I don't need it anymore. I've finished using it. So I'm going to press escape again. That deselects the spline tool. And now I'm going to press escape a third time because both the splines are highlighted in green, and I don't want that, so I'll press it a third time. So now they're deselected. So I have those splines now. I've put them in. In order to create the closed boundaries that we have in our sketch, or that we're being shown in the tutorial sketch, I have to get the standard line tool and just put two horizontal lines in there to close the boundary off. So I'm going to put one up here to close this top boundary, and then I'm going to put one down here to close this lower boundary as well. So let's do that. So line tool, just the standard line tool. I'm going to let one end of the line lock itself onto the end point of that spline. So I'm going to click there. And then I'm going to do the same over at the other end of the spline, and then click. And then I don't want to continue this chain of lines, so I'm going to press escape once. But I still have the line tool selected, so I can add another line to this lower spline. So click and click. And then I'm going to press escape once, twice, 3 times, and there I have my two closed boundaries. So there's a few dimensions that we're going to have to add in there, and we can see them on the PDF screenshot there. So we should be able to add those in relatively easily. But there's some constraints on those splines that aren't immediately obvious because the icons for them are relatively small. And those constraints are this one here, this one here, this one here, and this one here. And all 4 of those constraints are the same as each other. They are the tangent constraint. So if we try and put one of those into our spline, so here's our spline. Let's zoom in a little bit on this end of the spline. And what I'm going to do, I'm going to click on the spline itself. So I'm going to click there. Then I'm going to hold down Control because I want to select a second item. And you always have to hold the Control key as you click on multiple items. So I'm holding the control key down, and then I'm going to click over here on this reference line. So this reference line has been inserted into our sketch by the system as a reference to the top edge of our part. So you can see it's coincident with the top edge of the part. So it's a stand-in for the top edge, essentially. If we need to reference something to the top edge, we can use this reference line. So I'm going to click over here with control held, like that. And then this menu will appear. As I've said before, these quick access menus change depending on what items you have clicked on. So they try to offer you relevant tools and icons that are relevant to the things that you have just selected. So in our case, one of the things that it's offering is the tangent constraint. So I'm going to click on that, and hopefully you saw what the line did. So I'll just redo that again. I'm going to undo. You don't have to undo, but just watch the shape of the spline. So the spline currently meets the top edge, and there's let's estimate that angle between the top edge, which we're going to call 0 degrees, and this spline. So it's that little internal angle there. Let's estimate it at 5 to 10 degrees. So there's a 5 to 10 degree difference between the angle at the end of the spline. As the spline terminates at that end point, it's angled downwards by 5 to 10 degrees, whereas the edge that it's meeting is at 0 degrees. So therefore, if we were to look from above, down from above onto the part, we would notice that there's a harsh transition between this horizontal face and this new slightly angled face. So there's a sharp edge there. But when we put the tangency constraint in, so I'm going to click on the spline, hold control, click on the line, add tangency, the spline now meets the top edge, or the top line, the horizontal line, at horizontal. So you can see the transition from the angle that the spline has down here, which is arguably still 5 or 10 degrees, versus up here near the end of the spline smooths itself to 0 degrees. So you get a much nicer transition between this new face that we're about to create with the spline and this top edge of the part. So that's what we're going to do on all of the remaining 3 ends of our spline. So I'm going to zoom in on this one slightly, or this end of the spline. I'm going to click on the spline, hold down control, click on this reference line over here, and then add a tangency constraint. So I'm panning around here and zooming in and out. So I'm zooming in and out by rolling the mouse wheel backwards and forwards, and then I'm panning by holding the shift key, pressing down on the middle mouse button and dragging. So that's how you pan when you're in sketches. Because if you don't hold the shift key and you try the same thing, your sketch plane will rotate and it will be hard to work on your sketch. So an angle like that, it would be almost impossible to do any fine work on that sketch now. But if you find yourself in that kind of position and you're struggling to get back to looking at your sketch kind of from the right angle, you can press that icon at the top. So sketch view will take you back to the angle that you were viewing it from. So let's add those remaining tangencies in. So this end of the spline, click over here to the left whilst holding control, add the tangency in, click over here, we'll pan slightly, hold control, and then add a tangency in there as well. So all 4 ends of our 2 splines now transition into their horizontal faces very smoothly. You can see they've smoothed right out. So we've just got some dimensions to add now. So let's start over here. So we've got 45 and 3 for this one. So I'm going to get the dimension tool. I'm going to click on this little vertical edge. And I'm going to click on this point. And then I'm going to middle click or middle button click in between them somewhere to drop the dimension text. And then I've already been provided with a weak dimension here that I can just edit. So I'll double click on there and put 3 in there. think that's right. Yep. And then I've still got the dimension tool active, so I can click on this edge and click on this point and then middle click in between the two of them and make this one 3 as well. And then we're just repeating what we've just done essentially. We're clicking, middle button, enter the number. And then we've got a 50, so click, middle button, 50. So that's the upper spline more or less constrained now. So we've just got the lower one to do. So we've got a little 5 there, so I can just double click and edit that value. Then we've got a 38 to that midpoint, so from there to there is 38. And then it's 3.5 high, so 3.5. And then what about the other end? It's 40. So I need to pan across here slightly. You can see a new reference line has appeared there, and that's because as we put this 45 dimension in, we reference quite a small edge in there. So let's see if I can get it to highlight. There is the edge. So there's a small vertical edge left on the front of our part. If we want to see that it is there, there it is. It's that face. It's the edge of that face that we clicked on. And when we did that, the system brought that vertical face in as another reference line. So there's the reference line, which is essentially stuck to the front face. So it makes our job a lot easier, because it's easier to click on this infinitely long line than it is to kind of click on a relatively small face or edge there. So that's the system's trying to be useful, and this is one of the things that the custom config file does that we applied at the start of the session. So yeah, from there to there is 40, so from this line click to this point, click, middle button, 40, like that. So we finished the sketch portion of our extrude. We're happy, we've got 2 closed boundaries, we fully constrained the shapes that we need. So I'm going to click on OK, and then we should be looking at this screen. And as I always do, I'm going to rotate my view slightly so I can better appreciate what this extrude is doing. So it's been extruded by 85, and if I have a little drag of that and see what effect that's having, I can reduce it so that it doesn't quite break through the entire part, if that's what I wanted. So you can see the effect that that's having. I think what I'll do in this instance is I always want this extrude to break through to this front face. So rather than putting a static value in, like we've got currently, I'm going to see if I can put some logic into how deep that extrude will extrude. And I think I'm going to use this option, to selected. So that allows me to click on, in this case, a face of the part that I want to send the extrude up to. So if I click on the front face, the extrude will always extrude through from the plane that it was created on all the way through to this front face, as long as that front face still exists. If we make some edit to the part in the future where this front face no longer exists, then we'll have to come back in and edit this extrude and correct that error. But that's fairly adaptable as a feature now. It will adapt to changes in the part width. So if it's decided that the part needs to be a little bit wider, this extrude will still cut all the way through. Or if it's decided that it needs to be a little bit narrower, this extrude will extrude through less. So it's quite an adaptable way of setting the feature up. The other thing just to note while we're in here is that because our sketches were entirely within the boundaries of the part itself, the system has turned the remove material option on. We can manually turn that off, but we see no real effect then, because we're adding extra material where there already is material. So really we can only use the remove material in this instance, because not removing it has no effect. So I'm happy with that now. It looks okay. So let's OK that feature. The feature gets listed in the feature tree. If we need to edit the sketch, it's there, and we can edit its definition if we need it. So yeah, let's move on to the next portion of our guide. So in this section we're going to use a new type of feature that I think we've used once before very briefly, and that feature is the draft feature. And the setup of the draft feature doesn't require us to create anything such as a sketch before we can preview the feature. This is very much one of those features where the input that you need in order to create a preview like this is just to select some faces or edges off the part itself. So what we're going to do, we're going to get into the draft feature, and the two things that we're going to select are, we're going to select some faces or some surfaces that we're going to designate as the draft surfaces. So in our instance it's all these faces round the outside of the part that are highlighted in this yellowy colour, and they run all the way around the other side of the part as well, all the way back to this edge here. So we're going to designate those as the draft surfaces, and they're ultimately going to be angled inwards by 4 degrees. So hopefully you can see the original shape of the part followed this green wireframe representation here. So you can see that there used to be vertical, so that edge there used to be vertical, but when we OK this draft feature it will lean inwards by 4 degrees. So that's what the draft surfaces mean. They're the surfaces that you're actually going to change the angle of. And the other thing that we have to select is this, which is the draft hinge. And in our case, that's the face on the underside of our part. So it's the face which is sat on the front plane. So there's the front plane. That was the plane that we created our first sketch on when we were creating Extrude 1. And the face which is sat on that plane we're going to designate as the hinge. And that face won't change in size, whereas this top face here has had to shrink slightly in order to accommodate these side faces being angled in by 4 degrees now. So the draft hinge is the face that you designate as unchanging, whereas there's the potential for other faces to change size when you apply the draft angle. So let's do that. So let's orient our part in a similar fashion, like that. And then make sure that you've not got any faces selected or any edges selected on your part. So if you have, they will be highlighted in green. And to make sure that you don't have any, just click in some empty space on your modelling window there. So over here is fine. Then I'm going to initiate the draft feature. There's the draft icon in the engineering section of the model tab or model menu. Click on draft. It's not immediately obvious what this interface is or how you deal with it. So what I'm going to do, I'm going to click here on this references tab where the system is trying to draw my attention. And that's shown by the fact that the tab is shaded in this kind of pink colour. That is the system trying to get my attention as to something that's within that tab. So if I open the tab up, this looks a lot like the screenshot that we were working from before. So you can see the references tab is also open in that screenshot. And the first box that's waiting for some input is the draft surfaces box. That's why it's highlighted in green. You can see the other boxes aren't. So I'm going to start selecting those draft surfaces now. I'm going to click, and then I'm going to hold the control key, and then I'm going to click again. Still holding the control key, I'm going to click again. So that holding the control key down just before you click or during the click allows you to select multiple faces. And then I have to let go of the control key because I need to rotate my view round so that I can see the faces on the other side of the part. Then I'm going to hold control again and click, 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 like that. So that's all the draft surfaces. Those are the faces that I intend to angle inwards to put the draft angle on this part. So now I'm going to go down to the draft hinge entry box. So I need to select the entry box by clicking on it. There. Click where it says click here to add item. You can see the box is now active, it's highlighted in green, and it's ready for me to select the draft hinge face. And in our case it's this face, as we said before, that's on the underside of the part. It's the one that's coincident with the front plane there, so it's that face essentially. So we'll click on there. Then I'll kind of rotate my part round so I can appreciate what's happening a little bit with this feature. And I'm just going to do what we've been doing with the other features, which is click and drag this little yellow circle, just to get a feel for what the draft feature does. So you can see what's happening there. So let's put a very, very large draft on to fully appreciate what it does. So what is it doing? It's angling all those faces that I designated draft surfaces inwards, or alternatively you can put negative draft on and have them angled outwards. But we ultimately want them angled inwards. Those surfaces, as they swing backwards and forwards like this, they're essentially pivoting, and they're pivoting on the edge that they share with the draft hinge surface. So that's where the name hinge comes from, because they almost look like they're hinged around the edge that they share with the draft hinge surface. So let's angle them in the correct direction, that direction inwards, and let's double click on this value and enter 4 degrees, or just the number 4. You can see they're subtly kind of angled in now by that 4 degrees. This is where they used to be, this is where they are now. Everything looks good. It's worth just checking round the preview just to see that you're happy with it. Yes. So let's click on OK. So we've added our draft to our model now. So let's move on to the next section. This one's relatively easy. If we read the text, we're essentially adding a round feature to the top edge there. And the round feature is 8 millimeters radius of curvature. So we've kind of used the round feature already. The way that we initiate it is to click on one of the edges that we want to replace with the round feature. So I'm going to click on that edge there. So click on the round icon, and we get some odd preview there that something strange is happening back here. But that's because this round is far too big to apply to this edge or this chain of edges properly. But if we edit that value down to the value that we actually require, which is 8, that looks much better. And that preview now looks like the image that we're trying to emulate, which is this one here. So just before we OK that round, what has happened there? Well, I only selected that edge there. So let me temporarily undo that preview. I'll cancel the round feature temporarily. So all these edges round the top of the part that I'm clicking on here all run into each other tangent. So their endpoints are tangent. And the behavior of the round feature is that it will continue the round feature onto all the neighbouring edges as long as those edges are tangent to their nearest neighbour. So the fact that we took time to make those spline shapes tangent to their neighbouring faces or their neighbouring edges has now yielded a benefit, which is we don't have to go around clicking on every single one of these edges to apply the rounds to them. The round feature is happy to run round that chain of tangent edges. So we can OK that feature. So let's OK that round and see what we're doing next in the tutorial. So we're going to use the shell command in this section of the tutorial. So we can see a preview here of what the shell command is going to achieve. And when you're designing plastic injection molded parts, such as this part, it's preferable to create a part which appears possibly solid from the outside without actually being solid all the way through. So if you create very thick, very large blocks of material using a process such as plastic injection molding, then the resultant product can suffer from all sorts of undesirable effects, such as indentations in the surface, where the outside surface cools quicker than the inner material within the part. So it's much more preferable to design parts that have a relatively thin wall thickness, and then most of the material on their interior has been removed. And the shell tool allows you to quickly do that to your part designs within Creo. So the shell command here has been applied to the part as a whole. The thickness of the wall, the resulting wall of our part, has been set at 1.5 millimeters, so you can see that there. And then really the only input that the shell command looks for, other than the wall thickness, is what faces, if any, do you want to remove from your part. And in our case, we've removed this end face, so this end face has been selected for removal, and we've removed the lower face. That would be the face that was on the front plane there. So let's create that shell command now. So again, if I have anything selected on my part, I want to make sure that I deselect everything before I initiate this command. And then I have to find where the shell command is. There it is on my quick access, on my modeling toolbar. I think I'll select the faces first. So it's waiting for me to select any faces on this part that I want to remove during the shelling process that I'm about to set up. So this face I want to click. As soon as I click one face on the part, I should get a preview of what the shell command's going to do, or what the shell command will look like if I apply it at that point. So you can see that end face has been removed, a shell of 1.95 thickness has been created. So I'm going to hold down Control now and select the second face that I want to remove. So this face here, and you can see the effect that that's had now. It's removed those two faces. So the thought in this design is that this lower face here will butt up against a neighbouring face on the other half of our handle. So we said at the start this is the handle front, so this is the front of the handle, therefore there will also be a handle rear, which will be a separate part, and then the two front and rear will push up against each other, maybe with some mechanical fixing that will fix them together. Or maybe they would be ultrasonically welded, or some other method of joining them together. So that's why we don't want a solid face here. We only need that edge and possibly some mechanical clips to hold this part and its neighbour together. And then the thought is, if this is a hand tool, there's some kind of tool that's protruding out of this end. So we don't need this face either. The thought is there would be maybe a component or a part that butts up against here as well, and that holds some sort of hand tool. So that's why we've removed those two faces. But that's common that you will remove at least one face when you create a shell feature. So let's just quickly double click and edit the thickness to 1.5, which is what we need, and then we can OK that feature. And then see where we're going next with this. So this whole next section of the tutorial is all to achieve that with our part. So hopefully you can recognize that there's a pattern that's been applied to a feature or set of features there. So some features have been created to create this little nodule shape to provide grip for the user to actually grip onto with their hands when they're using the tool. So in this case, 3 small features were created over here on the left hand side. Those features were then grouped together, and then that group of features was patterned across the entirety of this top face of our part. So if we go back to where that process begins, which is up here, the first thing that we need to do is we need to create a small extruded circle shape there to create this little cylinder which sits on the top face of our part itself. So let's do that now, and there's the sketch that we need to create in order to create that extrude feature. So we'll go back in and we'll initiate a new extrude, and we're going to initiate it on the top face there itself. So I'm going to click on the top face, tell the system I want to create an extrude. The view will rotate round, and what we need to sketch is a circle. So I'm going to get the circle tool somewhere down here, click and click again, and then press escape because I don't want to draw any more circles. And then I'm going to edit the diameter to be 1.5 like that. And then what I'm going to do is I'm going to get the line tool, and I'm going to sketch a line from that point there where those three edges meet each other. So I'm going to click down into the center point of my circle, so right in the center of the circle there, click, and then I'm going to press escape once, twice, 3 times. And what I'm going to do now, I'm going to lock that line to be constrained to be vertical. So I'm going to click on the line, add a vertical constraint to the line. Then I can edit the length of the line. So double click and 15 millimeters. And now the position of the circle itself is being defined by the length and orientation of this line, coupled with the fact that the endpoints are locked at this end onto the part itself. So that is a coincident constraint on that point and the meeting point of these edges, and the center point of the circle itself. So that line is doing a job. It's holding the circle in position, or it's fully defining where the circle is on this face. The only problem with that is if I OK that sketch, the system sees that line as a piece of sketch geometry that it should use to help create the extrude, and that's not really what we intend. That line is only here to help us construct the circle and the position of the circle. So what I'm going to do, I'm going to click on the line and I'm going to turn it into construction geometry. So what that does, if you click there, the first thing it does is it changes the line font into this purple dotted font. So it changes the color and it changes the line font into a dotted font, and that designates that it is construction geometry, and that the extrude feature that we're about to create will essentially ignore that line. That line is only there to hold a solid line, which is the edge of the circle, in position, and the extrude feature, or any feature, will only really construct solid walls and faces and geometry from the elements in the sketch which are standard solid lines. It will ignore the construction lines. So that's OK. So we'll click on OK. We'll rotate our view to better appreciate what's going on, and then we're going to set the height of this particular little cylinder at 0.5 like that, and then we can OK that. So on to the next section. So we've done that essentially. We've created the extrude. And then in the next section, or the next 2 sections, we add a round feature to the top edge of the part of that radius, and then we add a chamfer feature to the lower edge of the part, the lower edge of the cylinder, where the cylinder meets the top face of our handle. So let's add those 2 things in now. So to add rounds, we know how that works now. We select an edge that we want to replace with a round, so I'm going to select the top edge of the little cylinder. Tell the system I want to create a round. Set the size of that round to 0.25. I get a preview, that looks okay. And then very similar sequence of clicks, but now we're working on the bottom edge. So I'm going to click on the bottom edge like that, click. And then this isn't going to be a round, this is going to be a chamfer feature. So that is the next icon along. And in this case, I want this as 0.15, like that. So those are my three features. So what I want to do now is I want to group those features together. And the reason that I need to group them is that I want to create a pattern of the three features themselves. And I'm not allowed to select multiple features and then create a pattern from them. I have to file those features away inside a group feature. So that's what I'm going to do now. So I'm going to select the three features in the model tree that I want to group. So I'm going to select that one, hold down Control, and click on that one, and then group them together. So that is the group icon. So click on there. They all get filed away inside the group. So you can see group, local group. Have a look inside there. Yep, there are my three features. There's another level down, which is the sketch for the extrude as well. So this is how the model tree behaves. You can have features stored away within other features, or you can have sketches stored away within features. So if you want to think about these sorts of features that have sub-features within them, you can imagine that they were a folder on your computer, just a standard Windows folder. So anyway, with that local group selected, so I'm going to click on the local group, the pattern icon becomes available, so I'm going to click on the pattern icon. And then the type of pattern that we're going to use here, if we temporarily go back to the guide that we're working from, is the fill pattern. So you can see the pattern type in that screenshot has been set to fill. And what we have to do with the fill pattern, so let's select the fill pattern first. So fill is the pattern type that we require. The system needs a little bit of input in the form of a sketch. So what the system's waiting for here is for us to create a sketch or to point at an already existing sketch that we've previously created. And that sketch will be a closed boundary of edges, and the system will try and create pattern members to fill that closed boundary. So in this instance, we're going to sketch on this top face of the part, and we're going to create a sketch which is exactly the same shape as the top face itself. So it will follow this chain of edges all the way around the outside of that top face. So in order to do that, let's go into this tab that the system's trying to draw our attention to. That is where the sketch is going to be entered into that box. That's why the box is coloured in green. It's waiting for a sketch to be entered in there. We don't currently have a sketch, so I'm going to click Define to define a new sketch. Then I get this little window, which again is looking for some input. That's why it's in green, that box. It's looking for a sketching plane. Now I can use a flat surface as a sketching plane. It doesn't have to be one of the datum planes. So I'm going to select that top surface of my part itself. Well, let's just click on Sketch and see what that looks like. That looks okay. So what I'm going to do now is I'm going to make a copy of the shape of this face. So I don't want to have to create a sketch manually. I want to essentially steal the shape of the face itself. So if the part gets changed in the future and the shape of this face changes, I want this sketch to automatically adapt to that change and modify itself. So the tool I'm going to use is this project tool, and what this allows me to do is click on any edge inside the part, so you can see these edges highlighting, and get a copy of that shape inside this sketch. But I don't just want to select a single edge, I want to select a loop of edges, because ultimately I want a closed boundary. So I'm going to set this to loop. What that allows me to do is click on any face, because obviously the faces all have a loop of edges around their exterior. So I want this face here, the top face. So if I click on that now, there's my sketch created. So I haven't had to actually sketch anything, any geometry myself. And as I've already said, if that top face changes size or shape, this sketch will also change. It is locked to the shape of the top face. So that's good. So I can click on OK now and exit this sketch. Then I get a preview of what the pattern is currently going to look like. So there's a few options that I can edit here. And if we have a look at our PDF, we can see some of them. So the spacing between pattern members should be set at 3.5 millimeters. So I'll set that first. So here's the spacing, type in 3.5, and the preview updates. So wherever there's a spot in the preview window, that is where the center point of our little cylinder shape will be created. So you can see how many of them there are there now. So let's have a look at some of the other settings. There's a border of 4 millimeters that's been applied to the pattern. And if we replicate that, that should trim away some of these outer pattern members that are too close to the edge of our sketch. So you might want to do this because in our case, if our little cylinders get too close to the edge of this top face, then the new face that they find themselves on is falling away rapidly underneath them. So the system has problems and issues with rebuilding these pattern members that are too close to the edge of our flat face. So rather than try and correct that in any other way, we can simply add a border, in this case a 4 millimeter border, so 4, and it will remove any pattern members that are less than 4 millimeters close to the edge. So yeah, you saw the effect that that had when we changed it. So if we change it back to 0, that's without a border, and if we change it up to 4, that is with the border. So it trims all those outer ones away. And then one final thing, just to give us experience of how the fill pattern works, I'm going to click and drag this angle measurement that is currently set to 0. And you can see the effect that that's having. So essentially, the default pattern at 0 is kind of following the horizontal and vertical axes within our part itself. So it's following the Y and the X there. And just aesthetically, that, to my mind, isn't as pleasing as a pattern that has a certain amount of angle to it. So I'm going to set this to 60 degrees like that. And in my opinion, it's only my opinion, that looks visually kind of more interesting than a straight X and Y pattern. And it also gives us some experience of what the rotation setting does in there. So I'm going to click on OK. And our pattern will take a second or two to rebuild, because obviously however many pattern members there are there, the system is having to rebuild those 3 features. Let's see if we can sort of estimate how many pattern members. So you can see over here it's added numbers to the axis in the middle of each one of these pattern members. So if I click in some empty space just to deselect, so these are little axes that are sat in the middle of the cylinder. And there appears to be at least 120 pattern members here. There may even be more. So it's had to recreate that collection of 3 features 120 times. So that's why when you make a change or you create the pattern, it takes a few seconds to rebuild the part. Now, because it's quite busy with all these axes and their numbers on the screen, I'm going to turn the display of axis, the datum axis display off, which is that icon there. You may have these 4 or 5 icons in a drop-down list, but if you click on an icon that looks a little bit like this plain one, you may get a drop-down list, and then you can select or deselect certain datum items to be visible or invisible. So you can see you can hide all the datum planes, you can also hide all the datum axes there, and it just cleans up the display a little bit. So what has the pattern actually given us in our model tree? It's given us essentially a new feature called pattern. So there's the pattern feature. We know that the pattern feature's got sub-features within it because it's got one of these triangles at the side. So if we click on the triangle, you can see there's a whole load of copies of our group that we created. So there's our group of 3 features that we had: extrude, round and chamfer. That is the position of them, and then it's just created duplicates of that and spaced them on that top face. So yeah, that's the pattern created. So let's move on to the next section, a little bit further down. Let's zoom out a bit. So the next thing that we're going to add is a common feature within injection molded parts. When you shell an injection molded part out, you remove a lot of the internal material, as we've already said. Now that is a manufacturing constraint. That is the reason that you have to do that. It's due to a constraint in the injection molding process where it doesn't handle thick blocks of material terribly well. So therefore you use the shell command, you scoop out lots of material on the inside of the part, you leave a thin wall or a relatively thin wall. But what can happen then, certainly on parts like this that are meant to be gripped quite tightly within the hand, the walls of the part might begin to flex, and they may begin to flex to a point where the function of the part or the perceived performance of the part by the end user is affected unduly. So one of the ways that you can counteract that is you can add strengthening features inside the part itself. So these features are known as ribs, and we're going to create a type of rib. As you can see in the screenshot there, we've got ribs that run across the sort of width of our part. So if someone was gripping this handle on from the outside, these ribs would aid in stiffening the handle up and ensuring that it doesn't flex to a large degree. So these are very common, these rib features, when you're designing for injection molding. So that's what we're aiming to create ultimately. But we need to begin with a sketch. And this is the sketch that we're going to create. It's a simple collection of 3 straight lines. That's all we're going to create. Just like that. And these are going to be sketched on the front plane. So if we go back to our part, so they're going to be sketched on that plane there. So let's do that now. So up to this point, we've not created a sketch in isolation. We've been creating sketches on the fly as we are creating a feature. This time we'll operate a slightly different way, just to illustrate that you can create most features this way, where you create a sketch first, you OK that sketch, and it exists on its own, the sketch, in the feature tree, the model tree, sorry. And then you can initiate a new feature and select the sketch that you've already created. So with most features you can work in that method. It's a little bit slower doing it that way, or you can operate in the on the fly method that we've been using, where you select a face, you initiate a feature, and then it drops you into the Sketcher interface straight away. So yeah, we're going to create a sketch on the top front plane. So click on the front plane, click on the sketch icon, which is that icon there. It's like an S-bend in blue. Looks like a spline. And then our first problem is that we're looking at the front plane from the wrong side. So I'd like to be looking from this direction so that I can see down into my part, and I'm not. I'm looking from this direction, from the outside of the part essentially, but we can change that direction. So if when I'm in my Sketcher mode or the sketch menu here, I click on Sketch Setup on the left hand side there. What this allows me to do, if I rotate off axis, one of the things that this allows me to do is vary the direction that I look at the sketch plane from. So you can see there, I can look at it from this direction, or I can flip. So I'm clicking on the flip icon here, 180 degrees round to the other direction, because obviously every plane has two sides, therefore it has two directions that you can view the plane from when you're sketching on it. So it's this direction that I want to sketch from. And then if we look at our reference material, the sketch in our reference material is oriented at 90 degrees to what we are seeing there, and we can change that as well in this sketch setup here. So if I change this option here from right to possibly top, we're getting there. That's now at 180 degrees away from where we need, so I'm going to select bottom like that, and all that's doing is the datum plane that it's chosen as its reference, it's putting it towards the bottom of the sketch now, whereas now it's going towards the top, now it's going towards the left, and now it's going towards the right. So yeah, in this case, bottom is what we require. So I can click on sketch now, and I'm ready to create these three lines. So we want these three lines, essentially a horizontal one there, another horizontal one, and kind of an angled one down here. So I'm just going to get the line tool, but I'm not going to sketch over the top of the part. One of the reasons I'm not going to is you can see that the patterned cylinders on the other side of the part are offering themselves up to have constraints placed on this line that I'm about to create. So you can see my pointer is snapping to all their geometry, and that's not what I need. That's a constraint that I will then have to go in and manually delete. So what I'm going to do, I'm going to sketch my lines over here. I'm going to set them up, and then when they're almost fully constrained, I'm going to move them across over here. So let's do a horizontal line. Try that again. Horizontal line. Yep. Press escape because I don't want to continue that line. And then down below here, perfectly vertically below the start of that first line, click, and then make a line which is equal in length to the first one. Click again, then press escape, and then go down here like this, and then press escape 3 times, and you should have your 3 lines there. So let's check some things. Some constraints were inserted when we sketch these constraints specifically. So that constraint there is holding that point on that line to be always vertical relative to that point on that line. So that is what I require. Is this one doing the same? Well, this one's doing the same between there and there. So let's investigate by dragging these lines around. Yes, when I drag the leftmost point on this line, the other 2 lines follow it. So that link has been inserted correctly, and then when I do this end, yes, that one has been inserted correctly as well. So that is what I intended. I intended them all to be horizontally the same length. This one, if you measure along its length, is a bit longer, but horizontally from there to there in a horizontal fashion is the same length as these 2 lines. So that's what I intended. So they're all 10 mil. So 10 for the width. There's an 18 mil gap between these 2. There's a 17 degree angle there. Yes, let's zoom out a little bit. So up to the top one is 55, so that's that dimension there. But if I didn't have a weak dimension, I could get the dimension tool and click and middle button like that. So is that one? Yep, 55. And then there must be a gap. So at this point, what I'm going to do is I'm going to zoom in on these lines slightly. I'm going to get the point tool. So there's the point tool. And I'm going to sketch a point at the exact midsection of each one of these lines. So that is the exact midpoint of that line. It's equal from either end of the line. So I'm going to click there. I'm going to do the same thing on this line, click, and I'm going to do the same thing on that line, click. And then I'm going to press escape twice to get out of the point tool. So what that's going to allow me to do is I can lock the midpoint of that line now onto that vertical reference line. So it allows me to keep these lines centered about that line there. And I'm going to do that right now. So I'm going to click one of these center points, click there, hold down Control, click on that reference line, and then make them coincident. So that is the coincident constraint, like that. And then I've forgotten to constrain that lower one, so that is 20 mil, but to the midpoint up from the right hand plane, I think, there. So get the dimension tool, right hand plane, up to the center point, middle button, and I've forgotten what I said, 20. So that is essentially the sketch that we need to create in its entirety. So let's click on OK, and then we exit that sketch. So that sketch now appears on its own in the model tree. So we've not really seen that behavior before, because all our sketches, because we created them on the fly, they got filed away inside their respective features as soon as we completed the feature. Whereas this one is present and visible in the model tree and in the graphics window here. You can see it coloured in blue there. So yeah, with most features you can operate in this slightly slower method as well. And it has some advantages and some disadvantages. The major disadvantage is the speed with which you can work in the other method, the on-the-fly method. But this one can be useful in some instances. So I've made sure that I've not got that sketch selected, because I want to click on it once I initiate the rib feature. So I'm going to initiate the rib feature now. Click there. It's waiting for some input. I kind of know that it's waiting for a sketch, but let's have a look in this placement tab anyway. Yes, it is waiting for a sketch to be entered into this box. That's why the box is highlighted in green. I don't need to define a sketch because I'm going to use this sketch. So I'm just going to click on the sketch in the model tree. So click, it accepts that sketch as input, and it provides me with a preview of what the ribs are going to look like with all the current settings that I've not yet edited. So that's what the ribs are going to look like. So what has it actually done there? So what it's done is, you can essentially think of it as it has extended the sketch line in the two directions that the ends of that sketch line are pointing. Yes, so the straight sketch lines have two endpoints, and then the line itself between the endpoints. So the endpoints you can think of as pointing in opposite directions. So what the rib tool's done is it's extended the solid material of the rib out in those two directions until it meets some existing solid material which is within our part. So that will be these faces here. But whilst it's extending in this direction and this direction, it's also extending in a kind of 90-degree direction away from the sketch plane. So it's extending downwards as well. So it's a combination of extending out in the two directions that the line is pointing, and then out at 90 degrees to the sketching plane. And it extends outwards again until it meets some solid material that's already been created within the part. So it would be this bottom face here that it meets. So there's a few things to bear in mind. If you create your initial sketch, so let's say we had created an initial sketch maybe on this top face, and then the system had tried to extend away into empty space down here, the ribs, it wouldn't have been able to create a rib at all. And if we reverse the direction of these sketches by clicking on this arrow, it cannot create any rib feature because it never meets any solid material in this direction. So yeah, rib feature is very useful, and it will do things like extend sketch lines, which is quite useful, but you have to be aware as to what it's trying to achieve. It's trying to extend your sketch in several directions until it meets some solid geometry or some solid part faces, let's say. And if it never meets any faces, the rib feature will fail. Right, so let's add some other details to this rib feature. So let's turn on the round internal edges, and if I zoom into one of these ribs, you should be able to see what effect this has. So that's the effect that it has. So it's essentially allowed us to create a round feature inside the rib feature itself. So that's quite useful. It saves us if we require a round feature. If it wasn't available in here as a button to click on, we would have to OK this rib, and then we would have to create a new feature which would be the round, and we would have to go around clicking on all these individual edges to add the round feature to them all. So it's a time saver. We can add a round from within the rib feature itself. There are a few others in here. We're not going to get too much into them. There's a top round as well, if that is of some use to you, and you can also add some draft. So I think we will add some draft to these ribs, and now because this readout is becoming a little bit crowded, and if we add the top round it gets more crowded, we can get a better representation of what these ribs look like by clicking on shape here, and you can see this is a kind of graphical representation of what these ribs look like currently. So you can see the round feature on the bottom there. Let's make that 1, and let's have a draft angle of 3, and let's make the ribs, yeah, let's leave them as 1.95 for the time being, and click on OK. So at this point I think I'll add something else in that isn't in the PDF, and what I'm going to add in here is I'm going to put some sort of link between the width that these ribs get set to and the thickness of the outer face of our part. So if you remember back to the shell feature, we set the thickness of the shell at, if we can get it displayed on the screen here, where is it? There, 1.5. So that was the thickness of the shell feature. The thickness of the rib feature, we've just left it at, I think, 1.95. Yeah, 1.95. In reality, a good rule of thumb is that the ribs should be around half of the thickness of the shell itself. So rather than calculate that ourselves, we can tell the system that relationship. We can tell the system that the ribs should always be, let's say, 0.6 of the thickness of the shell itself. So let's do that now. And the way we're going to do that, it's in the Tools menu, and it's Relations. So this allows you to relate one dimension to another dimension. So that's what we're going to do. So I'm going to click on Relations. I get this Relations Editor window open. And then what I'm going to do is I'm going to click on the rib feature. So there's the rib. When I click on a given feature, all the dimensions that govern that feature or that help us to create that feature are displayed. Now currently they're not displayed with their actual values, they're displayed with the code number that the system refers to them as. So So you can see I've got dimension 36 here, I've got dimension 34, I've got radius dimension 44 here. If I want to temporarily see what these dimensions actually are, their values, I can click on that icon there, switch dimension. Switch dimensions, and you can see in the description there it tells me what it does. It toggles between dimension values and dimension names. So currently we're looking at names. If I click on it, we get to see the values. So that's quite a useful thing to remember. So what am I going to do? I'm going to click on this thickness of the rib. So you can see there it says 1.95 millimeters thick. So I'm going to click on that, and that gets captured, that dimension, and entered into my relations window. So what do I want to tell the system? I want to tell the system the thickness of that rib must equal, so I'm typing an equals sign. And what do we want it to equal? We want it to equal the thickness of the shell. So if we now click on the shell feature here, try clicking on the window and then clicking on the shell. I think maybe we have to switch back to I'm being not very intelligent here. So the thickness of the shell appears over here. So that is the thickness of the shell. And again, I'm expecting that to be 1.5. So if I switch my dimensions, there it is. That is the thickness of the shell. So what I want to do is click on that now. So what I've done there is I've said to the system, calculate the thickness of the rib to be equal to the thickness of the shell. So that's not quite what I require. What I want it to be is calculate the thickness of the rib to be the thickness of the shell divided by 2. Or I think we said 60%, so we could do times by 0.6. like that. And that will make the ribs 60% of the width of the shell thickness. So if I OK that now, and you'll see nothing actually changed in terms of the thickness of the ribs, and that's because I have to regenerate the model and then it will update. So that is the regenerate key, or Control and G if you want to use the shortcut. So click on regenerate, it does the calculation, and there you go, the ribs have changed. So let's do another little test. If we were to edit the shell thickness now, would the rib thicknesses change with it? Well, let's try. So what I'm doing is clicking on the shell feature, and if I quickly want to change a value which is inside a feature, I can click on that icon there. I don't need to go all the way back in to edit the definition every time. Click on edit dimensions, the thickness appears there. I'll try and click on that. There we go. Double click on it. Let's alter it significantly. Let's go up to 3 millimeters. So we're doubling it. And the key thing here is watch what the ribs do. The ribs should get thicker as the shell wall gets thicker as well. So press enter. The system recalculates, and the ribs do get thicker. So the ribs, the thickness of the ribs is now no longer set by the user entering a value. It's automatically calculated to be 60% of the width of the outside shell. So I'm turning the outside shell back to 1.5 now and pressing enter. And then it recalculates again. And there you go. The ribs are now on the value that we need them. So let's add some more relations in. So we're still in the Tools menu. Let's get the Relations window open again. So Relations. So we need a new line. So I'm going to press Enter in the Relations window to go on to a new line. So what I want to do, let's see, what do we want to do? Well, actually, let's create a second rib feature, and then we'll link the two rib features to each other. So for the time being, I don't need the Relations window, so I'm just going to cancel there. No, let's OK the Relations rather than cancelling. So that's what I've got. Now I'm going to create a slightly different type of rib. So we're back on the tutorial again. The rib I'm going to create this time is a profile rib. So essentially this is what I'm looking to achieve. I'm looking to sketch a line that bridges the gap between the inner two faces of my part, and then that gap will get filled with material, and that is our rib feature. So a slightly different type of rib. This is a profile rib. So let's go back to our part, and I think because it's more interesting, I think we'll use this plane as our sketch plane. Originally in the PDF we were creating a sketch plane down here, but we learn a new skill if we choose this one here. So I'm going to click on the plane. I'm going to tell the system I want to create a sketch. The system's going to rotate round. So what I'd like to do, so if I rotate my views slightly off angle there, what I'd like to do is I'd like to make a reference edge from that face there. So I'd like to, in the same way that the front plane has been inserted as a reference line there by the system, and the top plane there has been inserted by the system as a reference line, I'd like to get that surface there on the part, and then that curved surface there on the part, and that bottom surface there on the part, all as reference lines. So how might we do that? So we're in the sketch currently, and whenever we're in a sketch and we want to manually add some references into the sketch, you have to click on the references button on the left hand side. If you remember, we went into the sketch setup before, but now we're going into references. Click on references. As we expected, we currently have the top plane and the front plane as references, so that's okay, we can keep those. But what I'd like to do is click on this face, and you can see I'm not allowed to click directly on the face there, and that's because there is no edge there, but there is a face, and this plane that I'm sketching on, the right plane, does actually cut into that face. So if I click on this option here, cross section, that's what that means, the cross. What that then allows me to do is click on that face, and where the plane cuts through that face, I get a reference line. So I'm going to do it for this face as well, and maybe across at the other side, that face. So you can see I'm getting the shape of those faces where that right hand plane slices through them. So the cross section button is very useful when there is no edge on the part there, but there is a face that crosses the plane that you're sketching on, the right hand plane. So maybe I'll get the bottom surface there as well. So you can see I've got an exact copy of the inside shape of the part there. So I can close my references panel now, and then I can begin sketching again. So what I want to do now is I'll probably use my project tool. Project. In fact, I won't use the project. I'll use the line tool. So line tool, and I'd like a rib that begins there, comes inwards slightly, then goes diagonally kind of down like that, then comes horizontally again, and then drops down to the floor of the part like that. So that's the sort of shape that I require. Then I'm going to press escape. And then, as I've said, we're doing things slightly different to the PDF now. I'm just going to put in some nice round values into this. So let's have that as 4 mil. Let's have an angle of 135. Let's have it 2 mil down from the top of the part. What else have we got here? So these values aren't super critical. Let's have this as 3 mil, and I think we're there. Yeah, so that's okay now. So you can see what I've done. Essentially, I'm kind of creating something similar to an extrude with this type of rib. But the key thing here is you don't have to draw solid lines around the outside edge of the rib. The rib will extend again, or the rib feature it will extend towards the part from your sketch lines. So I've sketched this outside boundary, and the rib will search for solid part material on this side of the boundary. So let's click on OK, and then I'll click in some empty space to deselect that sketch. There is the sketch now, and then I'll go back into the Model tab, and I'll click on the drop down menu at the side of rib, and it's the profile rib that I want to create this time. So the standard rib is just the trajectory rib. We're now doing the profile version. So profile, it's waiting for some input, and as I suspect, it's a sketch that it's waiting for. So I'll click on the sketch that I've created, and there's the rib created. And again, if I wrongly reverse this direction that it's searching away from my sketch line for solid part material, it cannot create anything, because it's going away from the sketch in the other direction now, and it never encounters a solid wall of the part to terminate against. Whereas if I send it in that direction, it does encounter some solid walls of the part that it can terminate against. So yeah, that's that one. So I think what we'll do, let's set it as something ridiculously large, so that will do. Click on OK, and then we fully intend now to relate the thickness of this rib to the thickness of these ribs. So let's do that. Tool menu, relations, we need a new line, and we need to click on the new rib feature, so I can click on the rib actually in the graphics window if I want. What is the thickness of it? Well, it's obviously that dimension there. So D52 must equal, and we could relate it to D38, or we could take a copy and paste of that, because that D22 is the thickness of the shell multiplied by 0.6. So we could do it either way. Yeah, let's do a copy and paste. So we'll do a copy, and then we'll do a paste, and then we'll click on OK, and then we'll have to do a rebuild or regenerate. So now that rib is linked to that, is linked to the shell also. So if the shell changes, the thickness of that rib will also change. So one last thing that we're going to do on these rib examples is, with this rib you don't get the opportunity to add additional features within the rib feature, such as the rounds or the draft. So let's add a manual round in here. So I'm going to click there, add a round feature, and then hold down Control this time and click on the opposite edge. So I held Control there because I wanted these two rounds to be defined by a single number. So now I can change this to, let's say, 1, and they both change simultaneously. And that's because I've added those two edges to a single set within that round feature. So yeah, let's leave that as 1, and then let's put another relation in that makes the radius of this round governed by the radius of this round. So it will be this rib feature that's causing that round to be sized correctly. So let's do that now. In fact, let's temporarily change this to something significantly different. Let's have 2. Yeah. So now we will be able to spot when this updates. So we're in the Tools menu still. Let's get the Relations window open. Let's create a new line. Press Enter. Let's click on this round feature. Click. Capture its dimension. There. D63 on my machine. Equals. Let's click on this round. So where is the radius? I think that is the radius because it's got an R in front of it. So equals that. Click on OK. Nothing appears to happen. That's because we haven't regenerated yet. So let's click on Regenerate and watch the larger round. There it goes. So now that round is being calculated, having its radius calculated from the round which is in this feature. So that's how you can easily link values together, either within a part or even within a large assembly as well. So let's check back with our PDF. So we've essentially done a slightly modified version of this page here. We've essentially created something like this, but a little bit further down the part. And then one final step, which is often quite useful, is just to create a simple extrude to remove some material from the rib features. So you might do this if you had a component which must sit within this handle that you needed to create some space for. So let's do that. Let's create a extrude on this plane. Extrude. I'm going to use the center point rectangle again. Center point rectangle. Press escape twice. And then what size is this? It's 25 and 2 below the surface. So that is 25. And then get my dimension tool and dimension from that reference edge down to there, middle button, 2, like that. Okay. And then I'll rotate round to ensure that I can see what's happening. So the direction is wrong currently, so I'll flip the direction. And then, is it on the top of there? No, it isn't. So I want to remove material, but I also want to send it up to this inner face over here. So I'm going to say, I don't want a depth. I want to say to selected, and I want to probably pick that face to begin with. Yeah, that looks okay. So it's cutting through there, 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 and then it's stopping before it cuts through there. So that's fine. So that creates a little bit of clearance there if I needed to add another component into this overall assembly of this part. So yeah, I think we've kind of covered everything now. Yeah, save your part, which I will do. So I'll just click on the save icon, which is that icon there. Click. I'm already in my work directory, so I just need to click on OK. Do not type anything there. So click on OK. That's fine. It's saved it. If I want to check if it saved it, it tells me that it has down at the bottom left there. So yeah, that's the end of this tutorial, and I'll see you next week.